Quin Travers, as he said, and our club has about 100 people in it, and we have, the reason that it makes it a really good club is that we have these monthly meetings where we have presentations from pretty high up people that can tell us about, at one time we had somebody show us, they were in charge of the rover on Mars, and they showed us all these pictures and they taught us all kinds of things. So you really learn a lot in the club, and it's only $30 a year to join the club. We have our brochures and cards up there on the table, and then we do observing sessions, and you get a subscription to a magazine, and it's just a lot of fun. A lot of people enjoy observing together. So tonight we're pretty lucky. We got enough clear sky where we're going to be able to see the planets really good. It'll be in and out of some clouds, but that's okay with planets because they shine right through the dim clouds. It actually acts as a filter sometimes. So we have a couple telescopes out there. So what we're going to do is one guy's going to be showing Venus. He has a telescope about this big, Hans Heino is his name. And he's going to be only showing Venus. So you want to be able to see that. And then I'm going to be showing with my big scope, I'll be showing Jupiter and Mars. And Eleanor will be showing a nebula and some other things. And also we should be able to see Saturn right before it sets, if I can get my presentation over with. I kind of want to run through this kind of quick so that we can get out there and get all the people to see all the different things before it sets. You can't turn those lights on? Yes, question?
Space station, by any chance?
I'm not sure if it's going over now or not. I could get lucky and it could come over, but I didn't look for that tonight.
Is that good? Or you want them down further? Okay. That doesn't down.
Or at least maybe closer. Okay, so this is our sky tonight with no distinguishable thing on there. And as you can see, one of the main things that we look for, and I'm just going to look at it from a layman's point of view, is the first thing you can see in the sky is these three stars is the Orion constellation, and that's the Orion belt. And that's one of the most prominent things you can see in the sky. Usually we look at that and then we look at everything else around it to figure out where things are. And then we have Jupiter up here. Uranus is right up there. This is the zenith, which means straight up. So Jupiter is almost straight up. The good thing is it's the clearest when you're straight up because the closest way to space is straight up. So anytime you start looking further and further that way, you're looking through more and more atmosphere, so you get less and less visibility. So it's optimum, but it's very hard for our telescopes to maneuver when something's straight up, because you almost have to twist it rather than move it. And then there's Mars, and this is the east, so things are rising off the east. And here's the constellations. You can see the Orion, kind of hard to see, but this is him holding his arm up, and this is him holding your bow and arrow or blanket. And then the Orion Nebula is right about there. And Eleanor will be showing you that. And that's a birthplace of stars, very big gassy cloud. And then some of the bright stars showed up. There's Capella and Rigel. And Sirius is one of the brightest stars in our sky. And there it is with the folk art on there. You can see the big snake. And we don't really, this is astrology. Years ago, this was very important because they had to teach this because it controlled the time, when they would plant the plants, the seasons. So the way the constellations were very important to them years and years ago, unlike we are now. But normally we're interested in the science part of it. It just helps us locate things by knowing where the constellations are. But that's about it. And then this is the western sky right now. And there's the Zenith straight up, and there's Uranus starting to head down, and there's Venus and Saturn. And this is about 7 o'clock. So we're just barely able to see Saturn before it sets. And what's neat about it is sometimes it'll look orange because it's setting. So it'll have like an orange, like a sunset as it gets lower. And Saturn isn't very dramatic right now because the rings are edge on, so it just looks like a straight line. If it wasn't, it would be a nice ring and you'd see the ring around the ball. But it just looks like a straight line, and since it's so low on the horizon, it's gonna be a little fuzzy. But the cool thing is you'll be able to see all 4 planets, the visible planets, Saturn, Venus, Jupiter, and Mars. Those are all the planets you can see with your eyes, 4 planets. Uranus and Neptune are very hard to see with the telescope. I'm gonna try to find it, but sometimes it's not all for sure. And then you can see the Milky Way. If we could see the Milky Way, that's what it would look like. Coming up. Here's showing the lines and the names. Triangulum Galaxy, constellation. Let's see what else you say. Oh, and then this is a very famous one we always look at, Cassiopeia. It's right in the galaxy, right in the Milky Way. There's a lot of things that we calculate, and then right there you can see the Andromeda galaxy showed up on there. We might be able to see that tonight. That just looks like a glow, but it's 2.5 million light years away, and it's 1 trillion suns. And to us, it's just a little glow in the sky. But that's one of our closest galaxies. So when you look at it, you're looking at 2.5 million years ago. Some of the farthest things we look at is about 70 million, I saw one time. So that's about as far as our telescopes go. 100 million and 300 million is, and those are on nice dark areas to go see them. Here's the folk art, and now I put on the orbits that you can see. That these planets travel, and day by day they're moving a little bit, but it's because we're going around the sun, and we're looking out at the planets, and then we're looking at the planets this way, and then this way, so that's why they're moving across the sky. So by summertime, by the end of summer, we won't see any planets because we're seeing them all now. When we come around the other side of the sun, we're gonna be looking out where there isn't planets at that time. Another cool thing to see is you see Venus is right there, and look at the orbit. Comes up and then back down. So that's all as high as it gets. Because you think about it as that's the planet that's closer to the sun, so it's not going around on the outside. It's following the sun, so you can see the actual orbits. It never goes up in the sky in the middle of the night, because it's always near the sun. So that's interesting, and it'll look like a crescent moon when you see it in the telescope. A little small crescent moon, even though it's so bright. And then here I tried to show the whole sky. This is looking south, and you can see Mars, Jupiter, Uranus, Saturn, and when you look at that, you're looking at the plane of the solar system. So when you see a couple planets in the sky, you're looking out at the plane of it. So you can almost imagine how those arc around. Imagine it in the sky. So tonight, there's always 4 moons visible on Jupiter, around Jupiter. Sometimes they go behind Jupiter or in front of Jupiter, and sometimes they just disappear in thin air because Jupiter blocks the light. They're all reflecting the sun, and they're always different every night. So tonight, this is the configuration. There'll be Europa, Io on this side of Jupiter, and then Ganymede and Callisto on that side. Jupiter for tonight. And what's really amazing is you can see them move over like a half hour, an hour, the configuration changes, they're moving that quick. And when they go in front of Jupiter, you can actually see a little tiny black spot right on Jupiter. That is a shadow of one of the moons going by. So you can actually see the eclipse, and you can see that real easily in the telescope when it happens. It just so happens that these are the moons. They're very different looking. And they believe water is on a couple of these, and there could possibly be life in underground oceans. I'll show you that in a minute. But Ganymede is the largest moon in our solar system, and it's almost as big as Mars. As you can see there, look at how big it is compared to Mars. It's quite large, and how big it is, and it's larger than Mercury and Pluto. And that's the scientists are getting much more interested now in these moons because they believe there could be liquid H2O under the surface on these moons because they saw them shooting up at one point. Europa, we now have the Europa Clipper that is heading there because they want to sample it to see if it can support life. They're not looking for life, they just want to see if it has the elements to support life. So the Europa Clipper launched on October 2024. It'll arrive in 2030. There was a point where you could put your name in the database, and I got my name in there. They took 1 million names and they put it on a chip in the spaceship. So somehow my name's on there, I guess. And then there they are working on it in the lab, in the clean room. You can see how big it is. And I believe it's one of the largest satellites with the wingspan. I believe it's 100 feet long. It has 9 instruments. So this is what they're going to be looking for. They believe that there's a liquid ocean underneath there, and they think there might be a lot more water than our oceans on Earth, believe it or not, because the depth might be a lot more than what we have on Earth. So they definitely want to check that out. This is just a graphic talking about the Clipper. And it's a very strange looking planet. They don't know. They believe it's the tidal forces cracking it, and then maybe water flowing underneath it. But they know there's something going on with a lot of liquid. Mars just was at its opposition on January 16th. And opposition means that the Earth is between Mars and the Sun. So it got much brighter and larger, and it was very good seeing. And you were able to see the polar cap on it. So by in May it'll be 145 million miles away because it'll be configured like this. Because Mars takes 2 years to go around the sun, and we take 1 year. So that's why it won't be for another 2 years to where it lines up like this again. But that's when it's closest we could see it. But you can see how when it's over here, it's going to be so far away that it's just a pinpoint. It was 60 million miles, now it's about 80 million. But we'll still be able to see it. You'll see a nice disc with the color and everything. There's Mars, that's what it would look like if you see it really good. I've seen the textures on it through the telescope before when it was close, but it has to be at the right time, right conditions. Now, Uranus, the season on Uranus lasts one long day for 42 years. That means that it spins very slowly. It does a lot of strange things that they don't understand. Well, I'll explain that in a second. It orbits the sun on its side, so it's not orbiting with the ring, it's going like this way, even though it's going this way. The ring's going in the opposite direction. It's the coldest planet in the solar system. I believe it's 350 below zero. And the atmosphere has ices in the atmosphere. And they saw rings around it when they went and visited with one of the ships. 27 moons. And then this is a picture that they took, I believe, with the Hubble, and they were able to see storms popping up on there, so they know that it's active and there's things happening on it. It's not just nothing happening. And this is a picture from the James Webb telescope that really showed a lot of, I think white is cold, so that's why it's showing so white, it's because it's freezing. It's the seventh planet from the sun. While being visible with naked eye, it was not recognized as a planet due to its dimness and very slow orbit. And I could barely find it in the telescope. Uranus is tipped over on its side with an axis tilt of 98 degrees. Uranus became the first planet discovered with the use of the telescope, because everything else was visible. So for once they were able to see something on a telescope, it was a planet. Uranus has a small ring system. The composition of its atmosphere gives its blue-green color. Its average temperature is 320 degrees, I was a little off. And a day is 17 hours, so it takes 17 hours to go around. Jupiter takes 10 hours to go around. That's that. Here's just some interesting facts about, it's believed that the Spanish named the area Hobe, the J is like a H, after the native residents, the Hobe Indians. By the way, this is where the Hobe Sound got its name. The British had a tendency to angelicicize most of the words they found and changed Jove to the Roman name for Zeus, and their version called Jupiter. The meaning of Jove is Jupiter, the god of thunder and sky, the king of gods in Roman mythology. Later during the American period, Juno was added as she was Jupiter's consort. So that's why they came up with the name Juno. Later, they created the Celestial Railroad, built in 1888, and it would take its unofficial name to the sites it traveled between Jupiter, Venus, Mars, and Neptune, and it was called the Celestial Railroad. 7.5 miles long, and it ended operation not too much longer. It only lasted a few years, 7 years. As you can see, there's Riviera Beach, and they had Juno, Mars, and Venus. So now, a lot of people ask me what's the best thing I got to see when doing astronomy. So I put a little slideshow together showing some of the things I got to see with my camera or with I've seen in the last 7 or 8 years that I've been doing this. And it was quite spectacular, the things I saw. But the real treat is showing everyone else. Thousands of people looked at my telescope, and now I realize I'm just the conduit that allows me to allow everyone else to see what's going on up there, which is a treat. But this was the comet that was in October. It was very visible in the sky. This was right after sunset, even though the sky looks blue. And somebody turned on their brake lights. I thought it ruined my photo, but it actually made the photo kind of neat. But, and this is the same comet through my telescope. And this version here, this is without doing any enhancements. But you can see the nucleus right in there pretty easily and a little arc around there. These are stars showing up around it. And this is holding my phone to my telescope. And if the moon was out, we would be able to get souvenirs for everybody, but the planets don't work with cameras at all. They just look like a spot. You can't hold it. So what I did was I enhanced it on this one, And you can see the green shows up a lot more, and you can see a lot more going on. This was another comet a few years back when the camera wasn't so great back then, as you could see. And this is Omega Centauri, which is one of the greatest things I've seen. We go out west, and this only shows up on the horizon for a short period around this time of year. Just comes over the horizon and down. It's more mainly for the people that live in the southern hemisphere. But it has 10 million stars in it, 17,000 light years away. And that picture doesn't do it justice because that's my phone in a real dark sky taking a picture of it down on the horizon. And you can still see how many zillion stars. But this picture I'm going to show you here is the typical Hubble picture of what it looks like. And they think it could be like a galaxy starting, like it's a neighbor galaxy of our Milky Way. So, like a satellite galaxy, they call it. They think that a black hole could be in the center of it. And the stars are extremely dense inside of it. And globular clusters, there's hundreds of these in our Milky Way, and they see them in all the other galaxies as well. And they're very odd because they don't go with the galaxy, they go in the opposite direction. And they shed stars, and there's lots of studies going on about these things. So, but they're very hard to see in our skies with the city lights. You have to go to a little bit dark skies. This was where I was taking pictures of the moon, and I realized there was two mountains where the rover had driven to, and I could see those two mountains with my telescope. So I tried to plot out where the rover traveled and put it onto my photo that I took of the moon. So this was my attempt. But the rover had traveled 17 miles, so I thought, well, I should be able to see that with my telescope. But this is like a river of lava, and this is the corner of it right here. This is this corner right here, and that's right where they landed. So they landed there, and they drove the rover in these configurations. This is the beginning of a mountain right here. And then, as you can see up here, I put that picture just so you remember. But here's my photograph, and see this squiggly mountain is this mountain right here. As you can see. That mountain down there. So here it is zoomed in more, and then I plotted on there where they drove the rover. But you can see that, it's like you could almost see that where that would be right there. So that just amazed me that I could see with my telescope. And that's photoing with my phone, holding it up to the telescope. And that's a picture of him standing on that ridge. That's just the full moon picture. These are some of the photos I've taken through the telescope. This was just typical moon, a little sliver moon, but the stars showed up because the light, when I bled out the light, we were able to see the dark side of the moon very, very prominent. And everyone knows that only one side of the moon faces Earth all the time. So as it goes around, it's always facing us on one side. It's just the sun hitting it. The sun will travel across it about 10 miles an hour every month, you figure, because it takes a month for the moon to go around the Earth. So, because on a full moon it would look just like that, only it would be fully lit. And that's an eclipse, a lunar eclipse, where the Earth is blocking the sunlight from hitting the moon. And when it does that, it turns red, right when it covers it all. And that looks really cool in the telescope. This doesn't do it justice, but it looks like a red ball out there. here's some other dramatic photos that you can get. And this I found, it almost looks like somebody put a name on a cape. And it's a mountain range. And to me, it looked just like my name, Quentin. To me, it is. So I don't know why they put that there. Maybe like the wind blew it around, now it's not quite. But I'm sure we can get up there and fix it eventually. And these are some other cool photos. I shot a whole video in October where Saturn went behind the moon. And the dark part of the moon comes right up like this, and it went right into the dark part. And this is a rocket taken off where I've been able to mount my phone to the telescope and then watch the rockets, follow the rocket. Because my telescope's manual, so I had to follow it. And this is a bracket that I use. It just mounts my phone to the lens, is all it does. Then I position it just right. So that's how I can get those. They call them occultations when a planet goes behind the moon or behind. And I've caught Mars twice and Jupiter once. Saturn, I'm sorry. Saturn. One day I'll have to get Jupiter. And this is the Orion Nebula, which you might be able to see out there. And this is in a very dark sky because you get all these stars when you go way out west. And that's a birthplace of stars, 1,500 light years away. But what's neat about it is when you look at it in the telescope, you don't see any color at all. But you snap a picture of it, and then you enhance the color, and you can see all these colors pop out. So it's amazing that the cameras get the color, but your eyes can't get the color. So they can help you see things better. This was the last eclipse last April. That's a sunspot getting ready to be taken over by the moon. That's the moon right there. And that's kind of like looking into the lens. You can almost see me looking in there. Interesting. When I looked in the telescope, I have a filter on it, and I was looking at the eclipse. This ejection was sticking out like this. And this is an eclipse picture from someone else that I found published. And it shows this big ejection that was coming out. And I saw that thing and I was yelling that I couldn't believe what I was looking at because it looked so pronounced. And it looked like a spark or something. And but I wanted to see how big it was, so I overlaid this graphic of the planets. And look at how big it is. It's almost as big as Jupiter. And all that is an ejection of fire coming out at the time of the eclipse. And that's Earth right there. It takes 100 Earths to span the width of the sun. So you know. So that shows you all the planets in relation to the sun. This is from Chiefland, Florida. It's a place called Astronomy Village that we go to that's out west of Gainesville. And that's where we get the best skies we can get in Florida. And they have a big camping area out there, and lots of people go out there and they have big star parties, and you look at giant telescopes. They're very friendly. You could sign up for the club for $15 or something and go out there and camp and look at everything. But this was a shot of the Milky Way, and that's the campers and things down there. But you can see the Milky Way very easily. It looks like clouds. I always mistake it for clouds coming up over the horizon. You think it's going to ruin your day, and then you go, wait a minute. It's the actual Milky Way. And that's the end of what I've got there. But I'll just show you the video. 1 second. Yeah.
I have a question
Oh,
for the
yeah,
audience.
sure.
When you talk about these thousands of light years,
Right.
I was wondering who in the audience can tell us how many miles is 1 light year? Come on, don't look it up, don't Google it, just answer.
It's like trivia, no phones.
I don't know, a trillion?
A lot more than a million. One light year is 6 trillion miles.
6 trillion.
So do the math when he's talking about something is, 150,000 light years, a million light years, I mean, it's.
Yeah, it's hard to comprehend all that stuff, right? But just so you know what a trillion is, I always tell people this little thing
10
about
to
a
the,
trillion.
how many?
No, this really makes you think. It's like trillion isn't even a number that we can comprehend. It's like you hear about it on TV and say, oh, a trillion, yeah, but like if you were to count to a million once a second every 24 hours, you would get to a million in a couple weeks. In a year, you'd count up to 30 million, okay? So to get to a billion, you would have to count for 30 years.
Wow.
To get to 1 billion. Counting 24 hours a day, 1 second. Right, now you're up to 30 billion, you're like, whew, finally. So now I gotta get up to a trillion. So a trillion is 1,000 billions. So that means it's 30,000 years to count to a trillion.
That's the government.
So it's like, so that you can't figure out. So I can understand counting for 30 years, but counting for 30,000 years, that's like beyond. Another cool fact to think about is if you took a ping pong ball and made it the size of the sun, 1.58 inches, and made that the sun, the Earth would be the exact size of a grain of salt, 14 feet away. And it would take 1 year for it to go around, and it takes light 8 minutes to get to from the ping pong ball to the grain of salt. 8 minutes. So it'd be moving about a snail's pace, right? So Saturn would be 140 feet away. It would be about this big. And Jupiter would be 70 feet away, about that big, from the ping pong ball. But the next ping pong ball closest to ours, which is Proxima Centauri, is 4.3 light years away. So I did the math and I wanted to figure out, okay, where would the next ping pong ball be with that kind of scale? And it turns out it's 700 miles away in Chattanooga, Tennessee. That's where it is, sitting in the hotel room. And then light going this fast would if you went 4 years, you would be in Chattanooga, believe it or not. And I thought I was wrong, because I said, no way is it gonna go this fast. 4 years you'd be in Chattanooga, but it works out. I double check. So that gives you an idea how big things are. And then the galaxy-wise, if you made our galaxy 3 feet big, the Andromeda galaxy, the closest one, would be 5 feet big, and it would be 60 feet away, 60 or 70 feet away. So that gives you an idea how far. There's no stars in between. And all the stars we see in our sky are only in our Milky Way. Always remember that. And all those pictures you see when you see all the stars, you're really looking through a window of stars at the other galaxies that are out there. So, something to think about that a lot of the people didn't realize. And the Hubble really taught everybody that there's a vast amount of galaxies out there. That they didn't realize that. They thought that all the stars, this was our universe here, but they realized that the universe was very big. I was going to show you some videos, but we should probably go right out and go see the planets.
Dark enough to start.
Yeah, it's dark enough. So I thank you all for coming.
Yeah.
Any questions at all about anything? Yes?
Is Mercury a morning star now?
Maybe. I think it is, yep. He means morning because it's either in the morning or the evening. Same thing with Venus.
Like Venus.
But it must be in the morning because I don't think we can see it now. Because it's always low on right after the sun sets, there it is. Or right before the sun rises, there it is. That's when you could see it. And you could see it pretty good, almost a tiny small star. It might almost be a naked eye object, but they don't really call it one. But any other questions? Nope.